Today you're going to take part in a refraction lab. Because of the fact that you are unable to be in a lab, I'm going to perform the lab for you, and you're going to look at the data that I accumulate and you're going to make an analysis based on that data. In this lab, we're going to use a semicircular glass prism. We're not sure about the exact type of glass, but we're going to use this prism and we're going to look at how light refracts as it passes from the glass into air. The following pictures will help you to understand exactly how the lab is going to be set up and how we're going to get the data from this lab in order to analyze it. In this first diagram, you can see that I've drawn a principal axis marked PA. I've also sketched the outline of the semicircular glass prism, and on top of that I have put a protractor that is lined up with the principal axis. The purpose of the protractor is so that we can mark off angles of 20, 30, 40, 50, and 60 degrees, and then use those lines to line up our rays from our ray box, so that we can line up the rays in the ray box, make sure that they travel through the glass prism, and then take a look at what the rays are that are refracted, so that we can determine what those angles are for those refracted rays. So the protractor now has been used to mark off those angles of 20, 30, 40, 50, and 60 degrees. And those markings are then used to draw lines from the outside of the semicircular glass prism to a point directly in the center of the semicircular glass prism. And these lines are there to guide us when we're guiding the ray of light through the glass prism so that we can see how this ray of light has refracted. Now, using the ray box, we're going to make sure that that single beam of light lines up with the 20-degree line that we've made. And then we'll notice that the refracted ray comes out at an unknown angle. A small mark is made so that we can determine where exactly the refracted ray is, and then it is labeled 1 because this is our first refracted ray. Now we can line up the ray with the 30-degree mark and then mark the second refracted ray. Now we continue with the 40-degree angle of incidence, and then we mark down the third refracted ray. When we get to the 50-degree angle of incidence, you'll notice that there is no refracted ray. In fact, if we look at the three marks that we have made, we can see that the angle of refraction is increasing and getting very close to 90 degrees. So somewhere between 40 and 50 degrees, we know that we have reached an angle of refraction of 90 degrees, and now at 50 degrees there is no longer any refraction. So hopefully you remember that at this point, total internal reflection is occurring. So we no longer mark an angle of refraction, we're going to have to mark an angle of reflection. We're going to label that ray number 4, because even though it's not a refracted ray, it is the fourth ray that we have drawn. Next, we move to an angle of incidence of 60 degrees, and as expected, this is also going to create a reflected ray, which we're going to mark down as ray 5. So when we remove the ray box and semicircular prism, this is what we see on our sheet. Now that we have our raw data, it's time to measure the angles. So I've oriented a protractor along the principal axis, which represents our normal. And it's your job to measure the angles of refraction, which are rays 1, 2, and 3, and the angles of reflection, which are rays 4 and 5. So what you want to do right now is pause the video so that you can measure these angles and fill them onto your chart that I've provided for you. I'm going to do the first one with you, and then it's up to you to do the rest. So on your chart, there are a few things you have to record. The first is the angle of refraction. And remember, the capital R represents refraction. The second column is for the angle of reflection. Well, in our first data point, we don't have any reflection, so that one stays blank. Then we have to figure out what sine of the angle of incidence is, sine of the angle of refraction, and then sine of the angle of incidence divided by the angle of refraction. Based on our protractor and measuring from the normal, our first angle of refraction is 31 degrees. There is no reflected ray. Sine theta 1 is 0.34, and it's important that you keep these values to just two significant digits. Sine of the angle of refraction is 0.52, and the ratio of sine theta I over sine theta R, or sine of the angle of incidence, divided by sine of the angle of refraction is 0.65. Now you can use the overlay of the protractor on our lab results to fill out the rows for the angle of incidence of 30 degrees and 40 degrees. Remember, for 50 and 60 degrees we got total internal reflection, so you only need to write down the angle of reflection, and the remaining calculations you don't have to do. Once you've completed the table, then you can answer the questions associated with this lab and submit the lab.